Scale types, which is something I just came across today for the first time. And I had a friend ask me, well, what is this theory of scale types? And yeah, I basically had no idea what it was, so I did what I always do when I don't know what something is. I looked it up on Wikipedia, and it gave me all this stuff: nominal categories, ordinal, interval ratio, and I was like, dude, what is this stuff? So I've tried to break it down a little bit for you guys here. Basically, there are four types of data that you could somehow get your hands on. You could get your hand on nominal data, ordered data, continuous data, and something called a one-dimensional vector space. So what do each of these things mean? Well, nominal data is just something like names, right? Nominal from names. So it means things like cats, dogs, rabbits. There's no way to like compare them to one another, although cats are clearly better. So let's say we had a quiz or a survey, and we asked people, what's your favorite pet? And 20 people answer cats, and 15 people answer dogs, and 5 people answer rabbits for some strange reason. So when we've got this type of data, what type of statistics can we use? Can we do with this? Well, obviously, I can tell you very quickly that the modal score, the most common answer is 20 here. But can I do anything else? And the answer is no, because actually, well, here's a picture of my cat. Yay, cat. But the answer is no. I can't work out something like a median or a mean because I've got no way to like compare, well, what does it mean to be cat and not dog and not rabbit, right? I've got no way to compare cat, dog, and rabbit. There's no scale for those three. There's just names. They're just categories. So for nominal data, things like names or categories, I can only use a mode. So this tells me that if I've got nominal data, I can use a mode, but I can't use a median or a mean. Well, what about ordered data? Well, if I have ordered data, that means that there's some sort of like better than or less than, so for this one, it might be how much did you like a film? Well, hate is worse than dislike is worse than meh is worse than like is worse than love, right? So I've actually got some sort of order on this data now. And when I've got order, that means not only can I tell you what the modal score is, which is meh here, but I can actually tell you what the median score is as well, the middle value, because which in this case happens to be like. If you count, 25 from each side, you end up with like in the middle. Why couldn't I do that with the previous example? Because I didn't have either sides. Like, should I start with cats? Should I start with dogs? Should I start with rabbits? It's very hard to know. In fact, there's no correct answer. But with this one, because there's an ordering, I can talk about what the middle value is, and I can also talk about my interquartile range and stuff like that. So I could say, oh, the top 20% of people either liked or loved this film, or the bottom 10% of people hated it, something like that. Now this raises the question, can I use a mean as well here? And the answer is no, because like what does it mean to be like hate 0.5? Is there anything between hate and dislike? Well, yes, but there's no category that represents it, right? How would I represent something that lies between those two? So because I've got discrete categories, I can only have a median and I can't have a mean, because something that lies between these two categories is essentially mean English. So if I've got ordered data, I can have mode and median, but I can't have mean. So this brings us to the third area, which is continuous data. Now, continuous data is where I've got, it must be ordered, and it must be nominal, of course, there must be some names, and there also must be some sort of sense of what's in between these two data points. So this might be something like, how much do you agree with this statement? And it could be, some statement like, cats are great. And, people give their answers. One might be extremely agree, two might be, yeah, kind of agree, four maybe disagree, and 5 maybe, nah, hate it. So in this case, something like 1.5 would make a bit of sense, because it sort of means you're sort of between like yay and so there is some sort of meaning. It's continuous. There's something in between these two answers. So in this case, as per the previous cases, I can still tell you that the mode is 2, and I can still tell you that the median score is 3, but now I could also tell you the mean, the average score, and that's going to be 2.84. And that's fantastic. So is this all that we have? What's the stuff with one-dimensional vector space? Why do I need to care about that? Well, it turns out there's one thing that's a problem with this. If this was like, how much do you agree with something? I could say 1, 2, 3, 4, 5. I could have it like that. But I could also have it -2, -1, 0, 1, 2. right? There's nothing stopping me just changing the values that I've put on each individual category. And this is the problem that we face, that there's no fixed point 0. There's nothing to like define what 0 should be in this with these answers to how much you should agree. Like, what does it mean to 0 agree with something? Like, you know, you agree or you disagree. It's a spectrum, but like no one's quite sure what 0 would be on that spectrum. And when you aren't sure what 0 is, how does it mean to be like twice something? So like, how do you agree twice as much to one thing as to another? It just doesn't make sense to even ask that question. So if we have continuous data, but no fixed point 0, we can't talk about like doubling something or tripling something because it's meaningless until we fix a point 0. So for continuous data, I've got my mode, my median, my mean, but I can't talk about ratios. I can't talk about doubling something or tripling something or being half as good, if you will. So that brings us to this funny thing, one-dimensional vector space. What's a one-dimensional vector space? Well, I personally don't like that term. It's too mathsy. Instead, we just talk about having a fixed point 0. If everyone can agree what 0 is, then we can agree like when something's twice as good as something else, you know? If you've got 0, you've probably got 1 as well, and then you've got 2, and then you can define twice, right? So it's quite nice to have this fixed point 0 that gives us a point of reference for everything. And it turns out most stuff actually has this fixed point 0 in the real world. If we talk about height, well, 0 meters would be like no height, and we can talk about doubling the height. You know, if someone's 1.5 meters tall and the other guy's 3 meters tall, he's twice as tall as the first guy, right? So we can talk about ratios here. Weight as well. Like, you know, let's say we have someone who weighs 45 kgs and someone who weighs 90 kgs. Then I know that I can talk about that person weighing twice as much as the first person. And I've also got 0 weight. 0 kgs is a fixed point 0 for weight. And time as well, 0 seconds, and I can talk about taking twice as long to do something. So most things have this nice fixed point property, 0. And this means that I can talk about, and you know, so on and so forth. And this means that I can talk about mode, median, range, and ratio, and in fact I can bring to bear a whole bunch of more sophisticated statistical instruments like geometric means and harmonic means that make life a lot easier if I'm dealing with different types of questions. So one-dimensional vector space just basically means anything continuous with like a fixed point 0 that everybody agrees upon, right? And that's all it is.